Okay, and this is probably the most complicated one on the sheet. Well, it's not that complicated, it's just more writing. And we are talking about this hemisphere kind of in relation with a cone. So it says a child's toy consists of a hemisphere with a right circular cone on top. Okay, so I'm going to go ahead and draw it. I guess I'm going to draw it over here so I don't run out of room. So we have cone on top, hemisphere on bottom. Okay, so something like that, like an upside down ice cream cone. The height of the cone is 12 centimeters. The radius of the base is 5 centimeters. Okay, so we said the height of the cone is 12. The radius of the base is 5. It says the toy is painted blue. Okay, wow, my handwriting. Part A asks you to calculate the length L of the slant height of the cone. Okay, so L, the L that it's talking about, is that guy right there, that slanted height on the cone. Anybody know a relationship?
It's 13.
Okay, why?
Well, because 12 squared, which is 144, plus 5 squared,
Okay.
which is
okay. What
5.
method are you using, Alston?
Pythagorean theorem.
Thank you. So we can use the Pythagorean theorem because we have a right cone right here. So 12 and 5 are the two legs. 12 squared plus 5 squared equals our slant height squared. And then, yes, we end up with 144, or yes, and plus 25. L squared. This happens to be a perfect, perfect, what is it called? Perfect cube or something like that.
Match?
So L, huh?
Match, maybe?
No. It has a perfect, or it has a specific name.
Pythagorean triple.
Yeah, yes, Pythagorean triple, yes. So 5, 12, 13 is a Pythagorean triple. All right. And then part B of this asks us to calculate the area painted blue. Okay, so this is a case where we have half a hemisphere, right? And we're just counting the outside that we need to calculate the area of. All right, so we would need the area of a right cone, but we want to slice off that bottom circle. So what was the area of a cone? A right cone? Anybody, what was the area of the right cone?
It was pi r squared plus pi r slant height.
Yes, exactly. So which of those two terms do you think we're going to take away if we want to get rid of the base? which one of those pieces, so surface area of a cone, a right cone, we said was pi r squared plus pi rl. Which one of those represented the base?
Pi r squared.
Yeah, the pi r squared. So that's the one we need to get rid of. Okay, because we aren't painting that. That's on the inside. So we're going to have pi rl. And then what was the surface area for a hemisphere without a base?
Two pi r squared.
Beautiful. 2 pi r squared. So that's going to be the area that is painted blue. And all we need to do is fill in the information we know. We know that our radius is 5. And we found our slant height to be 13. Okay. 5 times 13 is 65, right? I did that in my head, so I could be wrong. 5 squared is 25 times 2 is 50. So this would be 115 pi. And then its surface area, it was in centimeters, so this is centimeters squared. This was centimeters. Okay. Those are the examples. I'm just 15 minutes over. I'm very sorry. I will post pictures and the video of the whole meeting. Your practice is going to be doing problems just like this, but with answers such that when you calculate the value, it will match another value. The units may not match. Maybe one is in centimeters, one is in meters. They should be in the same dimension, if that makes sense. Any questions before we go? I'm so sorry that I held you up for so long.
I'm good.
Okay. All right. I'm sorry that I had to talk super fast. Obviously, I'm going to post the video so you can go back and go slower if you need to. Thank you, guys. And I hope you have a great day. Bye.
Bye.